Hi everyone, myself Harshita S. I'm currently pursuing my 6th SEM in Sri Venkateshwara College of Engineering. So my today's topic is all about the computer graphics and visualization. In computer graphics and visualization, we're studying about the very important topic that are the applications of CGV. So first we'll see what are the basics of computer graphics. So computer graphics is an art of drawing pictures, lines, charts using computers with the help of programming. Computer graphics image is made up of number of pixels. So pixel is the smallest addressable graphical unit that is represented on the computer screen. Now we'll study the major applications of computer graphics. So that includes graphs and charts, virtual reality environments, education and training, computer art, image processing, graphical user interfaces, computer-aided design, data visualizations, and entertainment. So most of these applications are very much used in our daily lives. So we'll briefly study what each one will briefly stand for. So first we'll come to graphs and charts. So an early application for computer graphics is the display of simple data graphs, usually plotted on a character printer. The data plotting is still one of the most common graphics application. The graphs and charts are commonly used to summarize functional, statistical, mathematical, engineering, and economic data for research reports, managerial summaries, and other types of publications. So typically examples of data plots are the line graphs, the bar charts, the pie charts, surface graphs, the counter plots, and other displays that are showing the relationship between multiple parameters in 2 dimensions, 3 dimensions, or higher dimensional spaces. So here is a simple picture of the graphs and chart that is plotted using the computer graphics. So the next application is our virtual reality environments. So the animations in virtual reality environments are often used to train heavy equipment operators, or it is used to analyze the effectiveness of various cabin configurations and control placements. With virtual reality systems, the designers and others can move about and interact with objects in various ways. And the architectural designs can be examined by taking simulated walk through the rooms or around the outsides of the buildings to better appreciate the overall effect of a particular design. With a special grow, we can even grasp objects in a scene and turn them over and move them from one particular place to another place. So, and how this is a simple picture of how the virtual reality environments look like. The next application is the computer art. So in today's generation, we all know that the computer art is one of most streaming application. So we'll briefly see what it is all about. So the picture is usually painted electronically on a graphics tablet using a stylus, which can stimulate different brush strokes, brush widths, and colors. Fine artists use a variety of other computer technologies to produce images. And to create pictures, the artist uses a combination of 3D modeling packages, texture mapping, drawing programs, and CAD software. So the commercial art also uses these painting techniques for generating the logos and other designs, page layouts for combining text and graphics. That is the TV advertising, spots, and also other applications. So a common graphics method that is employed in many television commercials is morphing, where one object will be transformed into another object. So the picture of computer art is displayed here. Next is the education and training. So computer generated models of physical, financial, political, social, economic, and other systems are often used as an educational aids. So models of physical processes, physiological functions, equipment, such as the color-coded diagram, are all shown in this figure. So you can see here the physical and the physiological process that are being done here can be clearly seen. This will help the trainees to understand the operation of a system. For some training applications, special hardware systems are designed. Examples of such specialized systems are the simulators for practice sessions, aircrafts, pilots, air traffic, control personnel, etc. So some simulators have no video screens. For examples, the flight simulator with only a control panel that is used for instrument that is nothing but our flying. Next is the entertainment, which is a most favorite application of most of the people in today's generation. And in entertainment, the television production, motion pictures, and music videos routinely are computer graphics methods. Sometimes graphics images are combined are live actors and scenes, and sometimes the film are completely generated a computer rendering and animation techniques. So some television programs also use animation techniques to combine computer-generated figures of people, animals, or cartoon characters with the actor in a scene or to transfer an actor's face into an other shape. So these are the things that are being done with the application of computer graphics in the case of entertainment. Next is the computer-aided design. A major use of computer graphics is in design processes that is particularly for an engineering and architectural systems. So in CAD, the computer-aided design or CADD, that is computer-aided drafting and design methods are now routinely used in automobiles, aircraft, spacecraft, computers, home appliances. Circuits and networks for communications, water supply, or other utilities are constructed with repeated placement for a few geographical shapes. Animations are often used in CAD applications. The real-time computer animations that is using the wireframe shapes are useful for quickly testing the performance of a vehicle or system. So an image of the computer-aided design is displayed here. The next application is the image processing. The modifications or interpretation of existing pictures such as photographs and TV scans is called the image processing. And methods used in computer graphics and image processing overlap the two areas and are concerned with fundamentally different operations. And image processing methods are used to improve the picture quality, analyze images, or recognize visual patterns for robotic applications. The image processing methods are often used in computer graphics, and computer graphics methods are frequently applied in image processing. The medical applications are also make extensive use of image processing techniques for picture enhancements in tomography and in simulations and surgical operations. It is also used in the computed X-ray tomography that is called as CT and position emission tomography that is PET and computer axial tomography that is CAT. So a visual picture of how the image processing actually looked like. Next is the graphical user interfaces. It is common now for application software to provide graphical user interface. A major component of graphical interface is a window manager that displays and allows a user to display multiple rectangular screen areas called the display windows. Each screen display area can contain a different process that is showing graphical or non-graphical informations, and also the various methods that can be used to create a display window. Using an interactive pointing device, such as mouse, we can activate a display window on some systems by positioning the screen cursor within the window display area and pressing the left mouse button. And next one is the data visualization. So producing a graphical representations for scientific, engineering, and medical data sets and processes is another fairly new application of computer graphics, which is generally referred to as scientific visualization. And the term business visualizations is used in connection with data sets that is related to commerce, industry, and other non-scientific areas. There are many different kinds of data sets and effective visualization schemes that will depend on the characteristics of the data. A collection of data can contain scalar values, vectors, or higher order tensors. So you can see what all the data visualization contain. It contains the data, the story, the shareability, and the particular design. Next, our next topic for today is the pixel. So we'll briefly study what is pixel and how it can be represented on a screen. So a pixel, that is short for picture element, using the common abbreviation pix for picture, is one of the many tiny dots that make up the representation of a picture in a computer's memory. Each such information element is not really a dot nor a square, but an abstract sample. With care, the pixel is an image that can be reproduced at any size without the appearance of visual dots or squares. But in many contexts, they are reproduced as dots or squares and can be visibly distinct when not fine enough. The instant of each pixel is variable. In color systems, each pixel has typically 3 or 4 dimensions of variability, such as red, green, and blue, or cyan, magenta, yellow, and black. So the basic pixel process function kind of like a string of dominoes. It starts with the trigger, which is the event that we are looking to track. This trigger can be a page view, a button click, or whatever we are looking to keep track of. Once that action has been taken, it triggers the pixel code, which triggers the network call, and the network call passes that information to the DSP in that process. With care, these pixels in an image can be reproduced at a size without the appearance of visual dots or squares. But in many contexts, they are reproduced as dots or squares and can be visibly distinct when not enough. So the intensity of each pixel is variable. In color systems, each pixel has typically 3 or 4 dimensions of variability, such as red, green, and blue, or cyan, magenta, yellow, and black. So here we have represented how basically the picture will be seen. So the picture element or pixel. So these are the points that are being joined to make a complete pixel. So you can see the points that are A, B, and the addressable point is shown here, and how a particular picture of pixel looks like. Next, how a pixel will be represented on screen. So this is a very important topic. So we'll see how it is represented on screen. A pixel is represented by a dot or square on a computer monitor display screen. Pixels are the basic building blocks of a digital image or display and are created using geometric coordinates. Depending on the graphics card and display monitor, the quantity, the size, and the color combination of pixel varies and is measured in terms of the display resolution. For our example, a computer with a display resolution of 1280 into 768 will produce a maximum of 98,3040 pixels on a display screen. The pixel resolution spread also determines the quality of display, and more pixels per inch of monitor screen yields better image results. For example, a 2.1 megapixel picture contains 2,073,600 pixels, since it has a resolution of 1920 into 1080. The physical size of a pixel varies depending on the resolution of the display. It will equal to the size of the dot pitch if the display is set to its maximum resolution, and will be larger if the pixel is, since each pixel will use more dots. Because of that, individual pixels may become visible, leading to a blocky and chunky image that is defined as pixelated. So depending on the color system, a different number of bytes can be allocated for specifying each color component of the pixel. For example, in an 8-bit color systems, only 1 byte is allocated per pixel, limiting the palette to just 256 colors. In the common 24-bit color system used for nearly all PC monitors and smartphone displays, 3 bytes are allocated, 1 for each color of the RGB scale, leading to a total of 16777 to 16 color variations. A 30-bit deep color system allocates to 10 bits each of red, green, and blue for a total of 1.073 billion color variations. However, since the human eye cannot discriminate more than 10 million colors, more color variations do not necessarily add more detail and may lead to color banding issues. This is a picture of how the pixel will be represented on a screen with all its covered dimensions etc. I hope you understood the topic. Thank you.